Hi, I am Adli Hamdawi. Today I want to explain about definitions and notation of first order partial derivatives. As shown by using definition, we know that we can obtain fx and fy. So we go to how to remember the formula. Keep in mind that the formula fx is similar with fy. Difference between the two formula will be highlighted in the figure. Okay, we look at the fx and fy. We know that the only difference with these two formula only in the bracket of x plus delta xy, and for fy fx xy plus delta y. So the difference between fx and fy only these two. So how to technique and shortcut way to solve. So when you found keyword using definitions, you can obtain fx from the formula and fy from the formula. Simple as that. So we go to the notations. With respect to x, we can get a delta z over delta x equal to delta f over delta x equal to fx. Same goes to with respect to y. So how to remember the formula? We have z equal to fxy. In order to differentiate of it, we use delta over delta x for differentiate with respect to x, and we use delta over delta y for differentiate with respect to y. So we can obtain fx over f and fy. So technique and shortcut way to solve this kind of question: by keeping y fixed and differentiates with respect to x, we obtain fx. By keeping x fixed and differentiate with respect to y,
Hello doctor, I'm Tanjame and my part for today is differentiation rules. Differentiation rules basically divided into three parts. The first is logarithms and exponential, the second is the trigo, and the third is the hyperbolic. For the trigo and hyperbolic, it's kind of hard to remember, so the best way to memorize it is to do more practice. And then there are three rules that is very important when we do the differentiation. The first is the product rule, the quotient rule, and the last one is the chain rule, which we usually use it in the composite function. And then the next part of my presentation is the partial derivative as a slope. When we do the partial derivative, we have to visualize we're given a function of two variables that is floating over the xy plane of a graph. So when we find the xz plane, that means we have to make our y become the constant, and then we find the fx, which is the rate of change in the direction of x-axis. When we find the yz plane, we have to make the x become the constant, and then we find the fy, which is the rate of change in the direction of y-axis. That's all from me. Thank you.
Hi, I'm Pang Ji-Chin from Group 7. Now I'm going to talk about the notations of higher order partial derivative. As we can see, there are four notations here. So, how to remember the formula? It is same with the notation of first order partial derivatives, which we use d over dx to differentiate respect to x and d over dy to differentiate respect to y. So there are some shortcut ways to solve. First, for fxx, we differentiate f with respect to x for 2 times by fixing the y. Next, fxy. We differentiate with respect to x by fixing the y first, and then we differentiate with respect to y by fixing the x. Fyx. We differentiate with respect to y and make x as constant, and then we differentiate with respect to x by making y as constant. The last one is fyy. We differentiate f with respect to y for 2 times by fixing the x. When solving the problem, we need to remember Euler theorem. Euler theorem states that fxyab is equal to fyxab. This theorem is applicable only if f fx, fxy, fyx are continuous and defined in an open space that contains a point AB.
Hi everyone, my name is Yongjing. So I'd like to introduce theorem 2, which is chain rule when we apply on composite function. So how to remember the formula? Firstly, we need to recall back the chain rule we apply when we have two functions for only one variable. For example, y equals to fx and x equals to gt, where f and g are differentiable. Then we have dy over dt equals to dy over dx multiplied by dx over dt. So for part A, function with two variables, from the diagram we can observe that whenever we have two or more arrows pointing to two or more variables, we use delta. When we have only one arrow pointing to the variable, we use d. For example, z equals to f, x and y, where x and y are differentiable functions of t, then we have dz over dt equals to delta z over delta x multiplied by dx over dt plus delta z over delta y multiplied by dy over dt. So the technique or shortcut way to solve is, if we have z equals to f and y, always write the final differential with 1, which is in this case is dz over dt on the left hand side, and for each product term on the right hand side, write the one shown in the blue color, which consists of z and t. Then for the cross term, which are the purple one, write the function which are x and y respectively. So that's all from me, thank you.
Hey guys, I'm Jason. So let's continue on theorem 3. So in this theorem, it actually is same as the previous one, but we just add another term. So in this case, we have x, y, and z. So let's say we have z equals to this function, and u, and v. So this is how we write our equation for these three terms. So I'd like to share some techniques when we solve this kind of problem. So the first step is that we list all the variables using tree diagram. Please take note that whenever we have two or more arrows pointing to two or more variables, we have to use delta instead of d. So that's it for this theorem. Thank you.
Hi everyone, I am Ang Xuting from Group 7. Now I am going to talk about the implicit function for function with two variables, z equal to fxy. If fxy equal to 0 defines y implicitly as a differentiable function of x, then we have dy over dx equal to negative fx over fy. Let's see how to remember the formula. In order to find dy over dx from an equation consists of two variables, we must find fx and fy. Then we put the fx at the top and fy at the bottom. Fx is partial differentiate the equation with respect to x, however fy is partial differentiate the equation with respect to y. Now I'm going to show the technique or shortcut way to solve this type of problem. Whenever we want to find dy over dx from an equation consists of two variables, we always let fxy equal to 0. Then we find fx and fy. After that, we substitute fx and fy into the formula. For example, 6x power 3 plus 5xy plus 9y squared equal to 7. So the important note to solve this type of problem is we must remember to move the 7 to the left side in order to make the equation fxy equal to 0 before we do partial differentiation. That's all from me. Thank you.
Hey guys, it's Jason again. So let's move on to the last theorem, which is theorem 5. So in this theorem, it actually is same as the previous one, but we have three variables in this theorem. So this is how we write our equations. And please take note that the equations are written in delta instead of d, because f function x, y, z define the function z as a function of two variables x and y. So in this case, we have 3y times x plus z and equals to these three variables. And please remember that move everything to the other side, while the right side will be equals to 0. So after that, we can do our partial differential. So that's all for this theorem 5. Thank you.